Hello there! So I wanted to create a new video on Cerebral and its signals, talking a bit about where it comes from, and also giving generally a better presentation, going step by step, using code to explain how this actually works. So let's get going here. What we're going to talk about is how we actually handle state flow today, and then we're going to quickly see how signals, like in theory, makes this better, and then we will just dive into the code so that you can see how this actually works. So the way we handle state flow today is that I just want to compare backbone, Angular, and Flux, and the way we handle state changes is that most stuff happens with a user event, like an input change or button clicked or whatever. And this is related to your view layer. And in Backbone, that's just called a view using a template. In Angular, it's called a controller or a directive using a template. And in Flux, it's just components. And the way this happens is that the view listens. I will just call these views for now. So the view listens to some user event, and that will trigger a function. Now, this function can directly affect the view, put state into the view, but it can also call other functions, which you typically do, for example, with Backbone. If you need to change a model based on a form, for example, you would trigger a model. But you start out with this one function. In Angular, that would be inside a controller or a directive, and you might decide to call a service instead to change your state. And the really great thing about that is that you get an abstraction up. So all the views in an Angular app has access to all the services, but you cannot access all the controllers, because you will most certainly get like this loop problem where one controller depends on another controller and the same controller depends on that controller again. But with a service, you get like this abstraction up, and all the controllers can depend on this one service. In Flux, you use a dispatcher. So this function that reacts when you get a user event will call the dispatcher, and then you can store some state in the store, and that will trigger a change event which updates the UI. So the problem now is how we define this function, what we actually do when we get this user event. So let's check out a very typical example. This is how it would look if you were building a Backbone or Angular app. Or Flux app for that matter. What you would do is listen to a user event, and either you would pass like the function you trigger might go straight to a service in Angular or an action creator in Flux, but they would do something like this. They would change some state, then they would do an HTTP request, and then you might have a success or it might have failed, and you're calling different functions, and it's just you have all these hard dependencies inside this function. And what to also notice here is that the name of this function is often what should it do. It's not what happened. So when you just go into the file where this function is defined, it's very hard to see what part of my application actually triggers this function. And to understand what the function does, you have to read each line of that function. Because you have all this code, you have like the implementation details of that function inside this one function. So you might have heard of functional reactive programming. And that aims to solve this very problem. I'm not like a brilliant FRP guy. I think it's quite difficult to actually grasp, especially when building applications. I can understand the simplicity in having an input and operate on that to give a new output. But when building applications, we have lots of other stuff like HTTP requests. We want to change state all over, and yeah. So the thing is, the great thing about functional reactive programming is that you will listen to an input. So you observe an input, and this when you go into a file where this is defined, you will see what caused these functions to run, because you see what kind of input it actually observes. And this might seem a bit strange, but this is really important, to go into the file that defines the flow and see where does it start and where does it end. It's really, really important. So that's the one thing. The second thing is that you get this, you kind of abstract up what's actually happening. So you do not have any implementation details. You just say, observe this input, then you do this, then you do this, and then you do that. So it's very easy to understand the flow. And then you can go into each of these functions to see the implementation details. But what we really need to get our heads around is the flow of the application. If you don't understand the flow, it's very, very hard to fix things and implement new things. The problem, which I barely mentioned with functional reactive programming, is that it's based on having an input. And so you start with an input, and then you trigger a function that receives that input. And then that function gives an output, which the next function receives as an input. And then that gives an output. So it's really, really great for having one input and like convert that to a new output. But that's really what we want to do. I can actually understand why Netflix thinks this is awesome, because they get something from the server, which all their examples on FRP are. You get something from the server and you want to convert that to some state you want to use to display the UI. It's great for that. But what we want to do is the other way around. We want to handle a user event, and maybe we want to get something from the server first, then we want to set some state, maybe there was an error and we want to do something completely different. And this is really hard to express with functional reactive programming. If you're a master in FRP, you might disagree, but that is my statement, and I think the poor adoption of FRP says something about how difficult it is to learn. But it's a statement for now. Maybe I'm totally wrong about that, but the things I just mentioned, it's hard to do with functional reactive programming. So what I wanted to build was something that would let you do the stuff that's really great with functional reactive programming, but still works like you would do with traditional programming. So signals in Cerebral allows you to do the same thing inside your view. So you have a user event and you call a function. Now this function does not have implementation details. It just knows what kind of flow it should trigger. So this one function you trigger from your view layer triggers a number of functions called actions. So in this case, we see that we have a signal called input happened, and this is to indicate what happened in the view layer that triggers this flow. And this is really important. As I said, if you just read this signal, you should understand what triggered this flow, and what does it do, and how does it end. And again, we only put in simple actions here. What's special about these actions is that they, though they do get an output from the previous action, they share the output. So let me put that in other words. Whenever an action gives an output, that output is put on the signal. So that means that, for example, the end with this action knows the output of do this, do that, do async, all these other actions. And that makes it a lot easier to handle the flow, really, because you do not have to isolate each part of the flow. Another thing is handling asynchronicity. So you can see here that it's not just functions that you have as arguments. You can also have an array. And this array indicates that the functions inside here, or the actions, will run asynchronously. And the third thing that's special about signals is the ability to output to paths. So, for example, with this async action called doAsync, you can actually output to a success and an error path. So if there is a success here, it will run the save result action. But if it gives an error, it will run the set error action. So it's very easy to do this conditional flow, which is very hard to do with functional reactive programming. One thing I also want to mention is that the actions defined in the array will run in parallel. And when all of them resolve, then it will run all the actions each of them resolve to. So doAsync and doParallel async will run first. And let's say both of them succeeded, it will run success save result first, and then save parallel result after it. Okay, so that's a lot of theory on signals. What's really great about them is how you implement them and how you can secure this flow in large teams and large applications. So let's have a look at that. Okay, so let's dive into some code. I have built a small demo here, and what we're going to do is something quite simple. I have built or implemented a small backend here. So we have two endpoints. And those endpoints, they just return a success, or alternates on returning a success and error. And it's just an ID that they return, and it's just a date now. It's just to have something to play around with. So when nothing happens now when I click these buttons. As you can see, we're getting errors here because we haven't defined any signals. But what we're going to do is, if we hit the first button, we're going to talk to one endpoint, and button 2 to the second endpoint, and both, we are going to talk to both endpoints. So let's dive into some code, and let's take a look at the application first. So the app is just a component, which, oops, error, we're not using that one, which has access to isLoading state and responses. And when we click these buttons, we just trigger signals, as we saw in the presentation now. You can just, from this function that reacts to a user input, we will trigger this signal function that will then start the flow of the state change we want to accomplish. And what we're doing here is we're just passing some data called button 1, and then we have the button 2 clicked signal, passing button 2, and then both buttons clicked signal, passing both. And then we render the responses, and as you can see, if the isLoading state is true, we will disable the buttons. Okay, so let's create a folder here called actions. And what I also want to show you is in the controller, we have the state is just isLoading false, and we have responses. And we have some default inputs here, and that's just the super agent libraries to actually talk to the server. Okay, so let's get cracking. Let us first define the first signal here. Controller signal, and that will be button 1 clicked. And what we want to happen now first is that we want to put our application in a loading state. So let us start this off by just creating an action for that. So the action will be called SetLoading, and that is just a plain function. And this function will receive 3 arguments: input, state, and output. So input will be whatever is passed into the signal and whatever previous actions has added to the signal as output. The second argument, state, gives access to our application state, where we can call different methods to mutate the state and also get state from our state store. Output will then output some new values to the signal chain. So what we basically just want to do here is say state set is loading to true. That is all our action is supposed to do. Export default set loading. Save that, and let's import this action now. Import set loading from actions set loading. Okay, let's add that. So when we jump over to the application now, it refreshes automatically. And if I press button 1, as you can see in the debugger, we have button 1 clicked, action set loading, and we are setting the loading state to true. And as you can see, our buttons are now disabled. So we can just reset that state now, because we want to do something more, and that is actually talk to the server. And this is an asynchronous action. And the way you define an asynchronous action is just to put it inside an array. That will make it run asynchronously. And the good thing about that is that you can actually see in your signal definition what actions are run asynchronous and what are not run asynchronous. So let us create that action now. New file, get something. I think I called the endpoint something. Okay, and that's an action, no, sorry, function, get something, input, state, output. And let's just export this, export default, get something. Okay, so what this is going to do, sorry, it's not get something, it's post something, because we're going to do a post. Okay, and now, as I said, we have this default input, so we can say input utils request post to something, and we get an error or a result here. So what we're going to do now is that since we have the possibility of a success and an error, we're going to give 2 different outputs here. And let's see now, if there's an error, we are going to output to the error path, and we are just going to parse the result. So even if it's an error, we can actually parse the result here, which will have an ID. Or we will output to success, and we can JSON parse result.txt there too. Okay, so this is all that our action is going to do. And since it's an asynchronous action, this state argument will not have any mutation methods. You can only get state, actually. And that is because asynchronous actions should not mutate state in your application. And we'll save that, and let's... Didn't I rename that? No. Okay. Rename to post something. Post something. And then let's put this, oops, sorry, into our app. Let's see. Post something. Okay. Post something, and post something. Okay. So now that will run. But we need to define these 2 outputs. So if we insert an object here, we can say success, and we want to add a success response here. Let's call it add success response, and if it's an error, we say add error response. So let me just quickly create these two actions now. Add success response, yes. Function add success response, input state output. And as I said, the result from the server will have an ID, which will be which will be the output. So it will be an input here, and we are also getting an input from where the signal is triggered, which is data. So let us use both of these values now. Let's say state unshift, so we put it at the top of the list. Unshift responses, and what we're going to put in there is input data, and let's call this success, and let's use input ID. Okay, so we add to our array at the top the input data plus success because it's a success, and the ID. So let's export default, add success response, and let's just copy that to create our other action here. Add error response, yes. Error, like that, and let's call it error. Okay, and we of course have to import these two actions, add success response, and add error response. Okay, save that. And if I now hit button 1, we can see that button 1 was clicked. We put the application in loading state, and we posted something, and then we had an add success response, which unshifted this text to our array. So that works, that's awesome. But as we can see, our buttons are still disabled, so let us fix that too by adding a new action here, SetLoading. Let's just do this by copying that one, SetLoading, and this should be false, and SetLoading, and SetLoading. And what we can do now is, after this array, this means that when all these actions we put inside this array have resolved, we can run this SetLoading action. Okay, let me just clean this up a little bit, like that. So let me, it should have refreshed now. So if we hit button 1 again, and as we can see, we did button 1 clicked, and we posted something, added error response, and we ran the SetLoading, and our button is now back. So if I click again, I should get the success. I click again, I get an error, and we see all of this working just fine. Awesome. And even though we have these paths, we can still use the debugger because it remembers what paths were run at each step in the memory of Cerebral. Okay, so what should we do now? I want to show you more things here. Okay, so what I can show you first is that if I copy this signal now, and this isn't the greatest example, but it's to show you, and I say button 2 clicked, and I'm reusing SetLoading, I'm reusing post something, which we are actually not going to do, but we are reusing SetLoading and SetLoading, and we can reuse add success response and add error response. So the question now is, should we create a new action called post something else, or could we do something about this? And I haven't talked about this before, but this has always been part of the master plan. And that is if I create a new folder here, and let's call that factory. And let's create a let's just call it get data. And this is also a function, though it's not that important that we, let's just use a constant here, get data, because this is going to be a factory. Export default get data. Oops, get data. Okay, so what we have the possibility to do here is pass some data into this factory, and it will return an action. So what we want to do is pass in the URL, because that's the only difference from post something and post something else. And this will return a function called get data, which will have an input and output, sorry, state and output, like that. And let's just copy our post something code here over here, and instead of indicating hard coding the URL, let's make that dynamic. This is kind of cool. Okay, so I'll save that now, and let's move over to main and get this get data instead. And that's factory. Should be named factories, but don't worry about that. Okay, get data. So let's go in here where we defined our action, and let's call this get data, and we will call get data something. And now we will use the same here to get data something else. And this shows another level of how you can compose all of this together. And it's actually really, really nice. So if I save this now, and oops, I did something wrong. Get data. That should be a function. Okay, let's say that again. And let's see now. If I hit button 1, it has added button 1, and if I hit button 2, we can see that button 2 clicked. And one thing I did not prepare very well is that you cannot really see it contacting the other endpoint. But let me click button 2 again, and it should give an error. And there you can see it. It's something else. But if I click button 1 and give an error, it's something. So you can see this working. So that is one part of what I wanted to show you, is like composing functions to make your signals even more powerful. Okay, so now let's take a look at how you can control. You know what? Let's add the both button clicked signal first. Okay, so what we're doing here is we what did we call it? Add both buttons clicked. Okay, both buttons clicked, and we still have SetLoading. But what we're going to do now is just, I want to show you that you can with an array you can define two different actions, and both of these will now run in parallel, and after they are done, they will, based on being successful or not successful, they will run these other actions. So if I save this now, I should be able to click both, and as you can see, it ran to get data, and then it ran add success response, and it ran add success response again. I hoped I had inverted this this alternate error success, so you could see that that you would actually get an error on one of them and a success on the other. But my bad, sorry. But as you can see, we are contacting still two different endpoints, and we can see very clearly how this is working. And again, we can just traverse back in time because it remembers the results and everything just works. So that's awesome. Okay, resetting that. Now we are going to take a look at how we can define how an action should actually work. And this lets you better control new implementations, so that when you are more team members and working on large applications, it will be easy for you to make sure that new stuff added or things are changed won't break the application. Let us take a look at how we can well, there are two different things we're going to look at. It's how we can define outputs on our actions to get help from Cerebral to alert us when we use those actions wrong in any signal chain. And there's also type checking on input values and output values. So what we're going to do now first is go into our get data. Well, actually, first we will just remove, or we can just comment them out really. So we don't have to change so much. Okay, so we have this one signal, and in get data we are going to say not const, but let's say let get data. Well, actually we can just have get data, and then we're going to return get data from this factory. And what we can do with these actions is that we can give them a couple of new properties. And what we're going to do now is that we're going to say that get data outputs two different outputs. So default are success and error, but let's just give them resolve and reject. And we of course have to change that here, and then resolve there. So let's see now what happens when we jump to our application. Oops, I've been debugging some here. Okay, so what Cerebral tells us now is that the action get data in signal button one click cannot find path to its resolve output. And the reason for that is because we are calling them success and error. But let's remove our paths here first, and then we should also see an error here. And now we see that the action get data in signal button one clicked has an output value. There should be these paths, resolve and reject. So it understands if something is missing also. So let's use resolve and reject here instead. And what we see now is that this is working again. Okay, so that was changing outputs to help you prevent errors when you define your signals. Okay, let's just keep that and take a look here again. So what we can also do is define what types we're going to use on the values. So instead of an array, we can say on resolve we want to have an ID which we get from the server, and that should be a number. So you can just use the constructors in JavaScript for number, boolean, string, object, and array. But you can also use a function which gets the value, and that means that you can use any type library you want, because you might want special stuff like I could return here if type of value is string, or if type of value is number, for example. You probably wouldn't do this, you would use a library to do this, but I just want to show you that it's possible. So Cerebral is not opinionated at all about that. And our reject also takes actually a number, but let's insert a string here instead, just to see if we can provoke some errors here. Okay, so when I hit button 1 now, it gets some data, and it hit the wrong, the rejection, which had the wrong type. So what it states is that there is a wrong output of action get data in signal button 1 clicked, and check the following prop ID. And that was because of of this type here, and we can change that back to number. The point with these errors are to prevent you from going to stack traces and stuff. You should understand by the error what you have to do. So if I click again, everything just worked because now the type was correct. So that is outputs. I also want to mention that we have this get data default output. So if I say that the default output is resolve, I do not actually have to use the resolve method here. I can just call output, and that will also just work. Let's see. There I got the error, and then click again, and I got the success. Okay, so that works. But we can also type check the input here. So let's make sure that when well, maybe we should do, no, let's do it where it makes sense. So this this action does not care about the input. It doesn't use the input. It only takes the URL from the factory and passes the result from the response from the server. But we have something here that, oops, okay, I admit it, I did something wrong and had to stop the recording. That's happened sometimes, but let's go in and check our add success response. This one uses some input, and what we can say here is that our add success response action should define some types on the input, and the input here is data, and it should be a string. So let's save that now, and let's you can reset this, and let's click and see if everything works as it should, and it does. But what if I go into the app now and I remove data? I say null instead. Let's see what happens now. I probably have to click once because that's the error, and then I click again. And now we got an error stating that you are giving the wrong input to the action add success response in signal button one click. Check the following prop data. So again, this is really, really nice because giving the wrong types of input or setting up your signals with actions that requires outputs and stuff like that, those are bugs. You have to fix those things. So it's really great that you get that feedback. And what you can also do is listen to general errors in Cerebral, so that these kind of error messages can be listened to, and you can react upon them, passing them to some service you use in production to give you some really good feedback on something that went wrong. But you can read about that in the documentation. So I suppose this is what I wanted to show you. I hope this gave you a good insight into why signals are implemented the way they are, and the power they give you to define the flow of your application, how you can reuse functions and even compose functions to make really complex flows that are easy to read and easy to understand. Okay, thanks so much for watching, and yeah, bye.